So thank you. Thanks everybody for being here. It's really an exciting day. It's exciting for me to have you all here and to be talking about Caltech Computes, which is really something we've been working for around computation at Caltech for almost a decade in terms of connecting computation, computer science, the information sciences with all disciplines on campus. And really the keyword in the title for today, and the keyword for today is disruption. So when you think about disruption, when you hear about disruption, you think of things like startups, Airbnb, Uber, all these sorts of companies that have changed the way we live our lives. The world's largest movie house is Netflix. It's not, the theaters that you go to. Taxis have been completely disrupted by Uber and Lyft and these sorts of things, and so on and so forth. And there's just so many examples of these in our lives today. And since this is a Caltech Alumni Weekend, Caltechers have really, driven a lot of this, right? So, you might not know it, but Airbnb, Facebook, Roomba, all of these have strong Caltech connections, and Caltech people really drove the technology behind these. I like to say that 2/3 of Facebook is Caltech, right? So Bobby Johnson and Adam D'Angelo, and they're the names that maybe you haven't heard about as much, but they're really core to the emergence of that. And it's incredible how much we've contributed to this. But that's actually not what today is about. So today is about a different kind of disruption. Today is about disruption not of technology, not of industry, but of science and engineering. And this is something that maybe you don't associate with the word disruption when you hear it. But the same thing is happening across science and engineering. You have, to point out at the obvious, Nobel Prizes, starting at the highest, the most visible awards. Economists these days have received Nobel Prizes focused on the building of a new field that bridges computation and economics, algorithmic game theory. Chemists have received Nobel Prizes where in the citation of the prize it talks about the computer, the algorithms being just as important for the chemistry as the test tubes. Biologists, you don't need a wet lab anymore, right? You need the computational tools. Well, you need a wet lab too, but, the computational tools, the algorithms are just as important. Astronomers, we're going to hear about this from George today. The Sky Survey data makes it so that machine learning algorithms are kind of the competitive edge. What can you get from the data? Because the data is out there available for everybody. What can you get from it? What insights can you draw from it? This is what distinguishes a research group these days. And kind of driving this, this disruption is the idea that these fields are moving closer and closer together. We're at a spot now where it's hard to distinguish sometimes a computer scientist as opposed to a chemist as opposed to a biologist, and we'll see that today in the talks. And what's driving this is that no matter what field you're in, there's a new core. Caltech is built on an intellectual core, right? Everybody in this room took their core freshman classes around physics and biology and chemistry and these sorts of things, and these days there's a new core, and this core is very different. It requires, probability, optimization, algorithms, networks, machine learning, statistics, these sorts of tools. And this is really driving all of the traditional disciplines. No matter what discipline you're in, you need these tools today, no matter what traditional field. And it's from this core that new fields are emerging, right? So when you take biology and you connect it to this core, you get bioinformatics or computational genomics or these sorts of things. When you take what else? Economics and add this core, you get computational markets, algorithmic game theory, these sorts of things. And so you really just have these amazing connections. And I picked these particular ones here because these are all ones where really Caltech has had a defining role in shaping these fields at the interface of these new tools, this algorithmic thinking or computational thinking combined with traditional disciplines. And the key thing about it is, I put all these books here because there's no one discipline that all these things are associated in. There's some economics in them, there's some computation, there's some electrical engineering, some math. These are not one field that everybody needs to learn that field in addition to their own. It's really something new, something different that has been driving the emergence of these disruptive new fields across science and engineering. And it means that educationally, in terms of research, structurally, in terms of our higher education institutions, our research institutions, something new is needed. And kind of the catchword, the catch-all that has been growing and referring to this is CS+X. And that's kind of the theme of our day today is, what happens when you take computational tools, computational thinking, and combine it with some other discipline, some other X. Something new happens, and today is about us sharing with you the exciting things that can happen when you do that combination. And so, this is a new thing, and so lots of schools are rushing to adopt this. So, Stanford, I know some of you here have also touched other schools in your educational career. So Stanford, these days has been really jumping all over it, as has Northwestern. They all have been introducing this CS+X story in the last 2 years or so. But this is an old story at Caltech. We've been doing this for a while, right? So these schools are late to the party. Caltech has been doing it for years. And in some sense, this convergence like these it's the reason for Caltech. We have Caltech. Caltech's role in the world is to create these convergences. And I like, this quote from Phil, who's in the audience, one of the trustees. He's sitting over here. I think really sums it up well. So, nowhere else can disciplines get so close, and so nowhere else can new fields launch with as much energy. And so, the pictures on my slides are meant to try to convey this, where you have this convergence, and this convergence leads to an explosion, right? And nowhere else besides Caltech can you have an explosion with as much power. Can these new fields launch as strongly as they do? And so, this has been something that Caltech is doing. CS+X has been something Caltech has been doing for an awfully long time, and awfully well. So I'll start with the recent ones. Just in the last 2 months, if you've been paying attention to the news, you might have seen this. Caltech scientists make Van Gogh painting out of DNA origami. We'll hear a little bit about this today from Lulu. Well, not this particular project, but some of this stuff, related stuff. We'll hear from Yisong today. Some of his work was featured in Sports Illustrated this summer. Probably not the place you go to look for Caltech research, but using human operators to train the cameras and all the cameras on ESPN and these sorts of things. Robotics, our courses. This in the past year we had an interdisciplinary CS+X course around mechanical engineering, electrical engineering, computer science, where they built and raced electric vehicles, or electric vehicle race cars with some autonomy and control in them as well. Robotics in space, right? So taking autonomous swarms of robotics around space. That one unfortunately won't hear about today, so you can ask me about that one in the breaks. And then another one you probably saw in the news, our robotics team, which has undergraduates from every part of campus, won an international RoboSub competition. So this was schools from all over the world. I really enjoy this one because I'm a swimmer and I go over in the pool, and if you get there early enough, you swim next to the robot in the pool. Very Caltech experience, right? So yeah, I can beat it, yes. Okay, so yeah, but it's not just a new thing. So those were all in the last 2 months. When you go back further, I guess this is a great audience to ask this question. How many people recognize all three of these faces? Yeah, some of you had a cheat yesterday talking to me. But so we have Feynman, Mead, and Hopfield here. And so, that puts the time period here as, 70s, 80s, 90s, right? And, these are in some sense, the birth of CS+X at Caltech. You have a physicist, an engineer, a computer scientist, and a chemist and a biologist getting together and teaching a class together. They really taught one of the amazing foundational classes for the field of CS here when they got together. And you look at what came out of that class and their students, and it's incredible. Right? You have the things that you maybe associate, silicon, VLSI. The things that maybe you don't remember but you use every day, optical mice, touchpads, computer music even, computer vision. And then the things that are shaping almost every tech startup today, like deep learning. So, neural nets, the first generation of neural nets began here with these three people. And, there's not a single tech company today that doesn't want to do deep learning for whatever their industry is, right? And the basis of that is neural nets. And really, John Hopfield was the person with these that popularized that. And then, of course, probably you don't associate this with Feynman, but in addition to all of the great physics, quantum computing, right? I mean, these are amazing things that came out of, basically, this combination of CS+X 30 years ago now. And in the meantime, lots has been happening as well. So institutionally, Caltech made a remarkable commitment to this in the early 2000s. And this was really prescient. I mean, there was no other school at this point that was making a commitment like this, not to grow CS as an individual discipline, but to grow CS as a core for an intellectual landscape. And so I really like this quote. So this is David Baltimore, the president at the time, Nobel Prize winner. Some say biology is the science of the 21st century, but information science will provide the unity to all the sciences. It will be the physics of the 20th century. Information science, the understanding of what constitutes information, how it's transmitted, encoded, and retrieved, is in the throes of a revolution whose societal repercussions will be enormous. Now, the only word I'd change for today would be I should replace revolution with the modern word disruption, right? And this is kind of the mission statement for today, right? And so, what this went, and where he was giving this quote was in the foundation of the Information Science and Technology Initiative, IST, at Caltech, which has been just a remarkable, force for reshaping the landscape here, the intellectual landscape at Caltech. And actually, I should note that this quote is something that I found not by digging through Caltech materials, but I found because as a grad student, I was listening to the Turing Award lecture from Dick Karp. And the Turing Award is like the Nobel Prize for computer science. And at the time, he was really amazed with what Caltech was doing in computer science. And so he spoke for about 5 minutes of his Turing Award lecture about the visionary view of computation in CS+X at Caltech. And so this is a professor that has nothing to do with Caltech, right? And so it was really, it's remarkable. And so it really shaped kind of my view as a grad student. And the sort of amazing foresight of the initiative doesn't stop there. So this is kind of the press release when IST was formed. And if you go back and you look at it, probably when they were writing this, they were throwing out these outrageous numbers that just made things seem, there's no way we can get this, but this sounds really impressive, right? So 25% of the faculty, 35% of the students, and reshaping the landscape. Well, this was an underestimate. I mean, it's amazing. This was in 2003, and at this point now, CS+X faculty have flooded campus. And it's not just that computer science and electrical engineering have hired these faculty, it's that other disciplines are bringing in researchers that need to connect with computation in their work, right? They depend on this connection with computation for what they do. And so, this is a few of the faces that have made up this surge. And these are actually just the ones in the last about 3 years, if I'm remembering correctly. And you really just have, an amazing thing. Oh yeah, and I couldn't even fit all the pictures on one row, so I added a few more there. And the really special thing about this is you look at them, and it's hard to even give them labels in the traditional sense. So my favorite example for this is Omer. He joined last year after getting his PhD in math, PhD in math, going to Microsoft Research for a postdoc, so computer science for a postdoc, spending 2 years there, and then coming to Caltech as an economist. So he's on the economics faculty here. And of course he has joint appointments in math and computer science, as we all do. We all have our joint appointments at Caltech. But how do you label somebody like that who's trained in 2 different fields and then that he has a faculty position in? And you can go across the board here. Fernando Brandao is another one where he was, across his career having positions across computer science, math, physics, and here he's joined as a physics faculty. And pretty much everyone here, Frederick is a philosopher who also works on machine learning and causality. It's really an amazing set of people. And so, you have all the labels in your program, but if you want to play a little game for yourself during the day, ignore the labels of what people are called and watch their talks and try to guess. For each session, especially the first 3, one is kind of coming from information sciences, CS or EE, and one is from the X, and I have a hard time telling which one is which when I see everybody talk. So I think that's pretty special. And so coming back to this quote, it was a huge underestimate in the way faculty would influence campus, and even more, it was an underestimate on the educational changes that were coming. And so if you look at the educational changes, this is data that I collected over 30 years, so probably overlapping with most of you, at least for a little while in your time here. And you can see, things bop along. Physics was a dominant factor on campus for a long time in terms of the in terms of the largest major. ES kind of was a catch-all. That's why it's so big. There were not sub-majors within engineering, and so, if you were anything in any type of engineering, you fell into that bucket. And then you look at 2003, the formation of IST, and at the same time, the formation of a CS major at Caltech. We were late to the party in having an official CS major, but we catch up quickly, right? If you look at things now, the CS majors are larger than the next 3 combined at Caltech. And when you add minors, it's over 40% of the undergrad population are minoring in computer science. And something that I'm particularly proud of, we've been working very hard at this, 43% of those are women. And it's not just the majors. When you look at enrollments, computer science is not officially in the core at Caltech, but you don't come to Caltech without taking computer science, right? So you either take CS1 in the fall of your freshman year, or you pass out of it and you take CS2. That's it. You have to have these no matter what discipline you're going to, and the students know this. It's not the faculty telling them to take it. It's, they know it before they've even met with a faculty member on campus. So every Caltech student takes CS1, 70% take CS2. When you look at even the upper level courses like algorithms, a hard mathematical theoretical class, 65% of Caltech undergraduates take algorithms these days. And the largest course on campus, it's not freshman core, it's not physics 1, it's not bio 1, it's not these courses, it's graduate machine learning. So there are over 300 people in the graduate machine learning class this fall. It's taught right now, and that's on campus. There's 21,000 if you include everybody that's taking it online. That's true. They haven't finished. The term's still going on. We'll see if they finish. It's a hard class. It's not these MOOCs that other schools offer. And if anybody here wants to learn machine learning, it is a great place. You really learn it through Yasser's. This is Yasser Abu Mustafa's course. It's a great course. So that's faculty education. In terms of the intellectual landscape, at this point, every major center and initiative, it doesn't matter what division it's in, has computational faculty involved. And so it's really, no matter where you look, you see computation, whatever your favorite corner of Caltech is. And you'll see that today. I tried really hard to arrange a set of speakers that covered almost every department or division. We missed geology. We couldn't get the right people in town today. So I apologize for that, but you can come up and ask me and I'll tell you some CS plus geology stories. But we really, you touch everywhere in this space. And, and it's incredible. So you'll hear about CS plus biology and, we'll talk about a lot of different things. But if you think historically at Caltech, mapping the brain and understanding the brain is really a combination of the biological and the computational methods. And Pietro who will be our next, or I guess speaking in the first session, has led the way in some of that work. When you think of what are the big challenges, mapping the genome, these sorts of things. Well, the big idea there is to really view information, to view DNA as an information capsule, and beyond that, to view it as something you can build with, something you can compute with. And we'll hear a lot about this today, but this is one of my favorite slides from Eric Winfrey. It's a little dated now, but there's been a few years of progress. But at this point, you can see a Moore's law unfolding, not for silicon, but for DNA. And so if you look at the progress with DNA folding or building circuits out of molecules and self-assembly, so even doing robotics out of these molecules. So robotics, you can actually build things that will be little robots and attack little components of cells. You have a Moore's law. You have doubling every 3 years. It's almost even the same pace as what we saw in silicon. In economics, CS plus economics has been an amazing strength, and Caltech has had a remarkable impact in this space. This is a place where I work, and so it was hard for me not to give the talk on this topic. But Federico will give a great talk on this later today. But Caltechers have shaped the way spectrum auctions are performed in the U.S. and in other countries. If you think of every startup that makes its money off of ads, I apologize for this, but that's because of Caltech. So just put the positive spin on it. You wouldn't have have these startups without the ability for them to make money off the ads, right? So, but this started actually in two folds. There were two competing companies when computational advertising, these ad auctions started, and both of them came out of Caltech. One came out of faculty working with Idea Lab, and one came out of an undergrad alum who was eventually working for Google and through that. And so you really, both trends, they were even Caltechers competing to each other. Net neutrality and the understanding of network economics of ISPs, Caltech again led the way for this field. The sharing economy, Airbnb, grew out of Caltech graduate students, and then Facebook, I already said, two-thirds of Facebook is techers. And even today, something that you may have heard about over the news is Apple embedding privacy into their cloud, into their things, with a new tool called differential privacy. That is something that, again, is Caltech born and bred. So the idea of how you protect privacy in a provable way in your cloud systems is something that came out of here and came out of our work connecting computer science and economics. Physics, of course, quantum computing, you'll hear a lot about quantum cryptography. Another MOOC, if you want to learn about this, Tomas Vidic is teaching a MOOC right now on quantum cryptography. And it doesn't have 21,000, but it has over 10,000 students in it right now, and it's phenomenal. So I've been watching that. I've been learning that this term. Modeling of flows and complex networks as well is something that Caltech has been leading the way. And these sorts of networks, in a lot of places, they're driven by physics. But here, it really is something that connects physics and biology. And, I teach a course on this, and I'm always amazed by the students coming in and saying, I want to study networks, but I want to study it in this particular way. And so we have students working on chemical reaction networks, talking to students working on networks in the brain, talking to students working on social networks, economic networks, legislative networks, these sorts of all over the place. Astronomy, we'll hear from George about the sky survey stuff I already mentioned. Robotics, I mentioned the robotics team, but actually, autonomous vehicles, again, Caltech was leading the way here back in the 90s, where we were competing in the DARPA Grand Challenge and doing darn well, and it's beating CMU, beating Stanford, beating these schools that are considered the fathers. I mentioned, I had this on the previous slide, but I didn't mention it, but this picture on the left is from a company that one of our graduate student alums founded, Kiva Systems, which now basically provides the robotics that manage warehouses for every major shipping, every major company, basically. So this is any package that's ever delivered to you is carried at least a little while by one of these robots that was designed at Caltech. And of course, Mars. Not many schools can talk about putting robots on Mars. Sustainability, we'll hear about energy from Stephen Lowe later today. And we have, power grid was really shaped here. The transmission lines, I was learning yesterday actually how much Caltech had designed, the transmission system, the grid that we have today. And then these days we're really engaged in rethinking how it should work around lots of these issues around electric vehicles, demand response, integration of renewables. And depending on where you parked today, you might have seen one of these little boxes in front of your car if you came in an EV. And so this is one of our current experiments. I think Stephen might mention it in his talk later today, but our group, I work with him on this. We have 50 of these chargers over in the California parking lot, and to warn you, we're running experiments on how you can control and manage EVs and their charging capacity to provide a service. Basically, EVs can be large-scale storage for the grid, and these little boxes are letting us demonstrate that. And then climate modeling is another huge thing that's going on Caltech. You can't model climate. You can't understand clouds and how they're going to impact the climate and how they're going to impact weather without huge computational models. And there's just enormous algorithmic challenges to making that happen. Geology is another one. There's if you have the opportunity and are interested, you could join the Community Seismic Network. So you can put an app on your phone, you can have a little sensor in your house, and now all of a sudden you can get seismic monitoring, not from just a few big devices around the city, but everywhere. And imagine the data that you can do with this. You can recognize earthquakes early, you can warn, you can give actually a couple-minute warning to a city that the earthquake is coming because of the propagation of the waves if you can have these sensors densely around the world. And so you can do things like make sure the elevator doors are open and they're at a floor, open the firehouse doors so that the fire engines can get out and not be locked in because the earthquake destroys the openings and these sorts of things. And so there's a bunch of projects going on campus around that. medicine, we won't hear too much today, but there's a ton going on in medicine. Tom will tell us about chemistry, math, and sports, all of these things. I could fill the whole day with just these little gambits of how Caltech has shaped CS+X, and I think you'll through the day get a sense of how exciting this opportunity is and how much Caltech has invested and shaped these fields. So here's the outline of the day. You have the program in front of you. We're going to cover data, biology, physics, economics, chemistry, and energy. And maybe the most important thing today, you'll hear all the talks, of course, but at the end of the day, we have students. So we have about 25 or 30 students and postdocs who will come, and we'll have posters for you during the reception. And so you can talk to the people on the ground and hear about what they're doing from their mouths, and it'll be exciting. So with that, I will end my part, and we'll move on to the main event, which is CS+X. And the first one is going to be CS plus data.